This video shows examples of the questions on homework number 402. The first task is to find the slope when given 2 points. You'll notice that the slope formula is shown over here on the right. Once you've identified your first ordered pair and your second ordered pair, you can set those values up in this subtraction fraction by simply writing your fraction bar and a subtraction sign in both the numerator and the denominator. Find your y2 value, which is 4, put it in the first position. Find your y1 value, which is 7, put it in the second position. You'll do the same with the denominator, x2 and x1. Be careful of your double negative signs. Use a calculator to help. Remember, when you have 2 negatives in a row, it switches to a positive. If your denominator has a 1, you should reduce your fraction to an integer. Let's try this again with the second one. Set up my subtraction fraction, y2 minus y1 over x2 minus x1. If you get a 0 in your fraction, you have to go one step further and interpret that answer. A 0 in the denominator, or dividing by 0, is never possible, so this is undefined. And if you can't remember, simply turn on your calculator, type -4 divided by 0, and if you get an error, that means it's undefined. Question number 3. Set up your subtraction fraction. Start with your y2 minus y1, x2 minus x1. This time, I got a 0 in the numerator. And when you have nothing, and you divide it amongst 8, everything gets 0. Okay, last problem. Subtraction fraction, y2 minus y1 over x2 minus x1. So I get -1 over 13. Alright, let's move on to section 2. Oh, the rest of section 1, I should say. This task asks you to write the equation in slope-intercept form. So we're given 3 graphs here. So remember, if you are written in slope-intercept form, then this number is the y-intercept, and this number is the rise over run, the rate of change, or the slope. But you need 2 points to find a slope. So let's take a look at this blue line here. I'm going to look for some perfect corner points. I see one here at the origin. And I see one down here. I also see one up here. Now you don't need 3, you only need 2. But if I did it right, the pattern should be the same. I'll start from the top point here and I'll count my rise. -1, -2. Oops, sorry. Using my pen. -1, -2, -3, -4, -5 is my rise, and +1, +2, +3 is my run. And my y-intercept, or where I touch the y-axis, is the origin. So the y-intercept is 0. So when I go to write this on the line, I'm going to write a y in equal sign, and my slope is -5/3 next to the x, and my b is 0. So you can write +0, but it's best to leave it off. All right, let's take a look at question 6. Again, we're looking for 2 perfect corner points. Usually your y-intercept is one of them. And now I see this one here, but I don't see any others. So I see that my y-intercept is 3, right? 1, 2, 3. And now my slope is the directions of the rise and the run between my 2 points. I'm going to start with my lower point this time. The rise is +1, +2, +3, +4, +5. And the run is +1, +2, +3. So very similar to the last question, except my sign is different, which makes sense since this is an uphill line, and that was a downhill line. So my equation this time is 5/3 x plus 3. Now my last one is a horizontal line, which is a line that has a slope of 0. So I'm going to have 0 x's. but I have a y-intercept of -4, so that's my whole sentence. If I found another point along this line, I would be rising 0 and running 2. A rise of 0 and a run of 2 is a slope of 0. So that's why I have 0 x's. Okay. This last section here asks us to solve the following equations using our inverse operations. I'm going to subtract 1 from both sides here. And then in my last step, the opposite of dividing by 5, right? G divided by 5. The opposite of dividing by 5 is multiplying by 5. So my answer is G equals 25. Number 13. My number here, the constant, technically that minus sign that comes after it belongs to 6y. So this 3 technically is positive. So the inverse is -3. Rewrite, compute, and my last step would be to divide by -6, giving me a final answer of +5. Alright, last one. -12 from both sides. Rewrite carefully by bringing this sign down with my fraction. Now, when you have a coefficient that's a fraction, you don't divide, you multiply by the reciprocal. Use your calculator. The next set of directions ask you to determine whether the equation has one solution, infinite solutions, or no solutions, and then actually solve. Remember, in order for you to have one of these special solutions, that's the infinite or the no solutions, you can only have 2 terms on the left or right side, 2 or less. Can't have more than that. And if the variables are a perfect match, then you have one of these special solutions. If the constants are a perfect match, that's infinite solutions. If the constants are not a match, that's no solutions. And if the letters and the variable letters and their numbers are completely different, then you have one solution. So let's take a look at our first sentence. We only have 2 terms on the left and 2 terms on the right. That's great. Now what we can decide is, do the variable terms match? Yes, they do. So that means we have one of these special solutions. I should look at my constants next. The constants are a match, so that means this problem has infinite solutions. You can write the English word, or you can write that math symbol that I just did. It's like a sideways 8. It does say to solve, so I can prove this has infinite solutions, because when I subtract the variable term from both sides, it disappears, and the statement that remains is true. That's why it has infinite solutions. Alright, number 12. I have more than 2 on this left side, so I need to do some distributing before I can start to take a shortcut. So 2/5 times 15x is 6x. And 2/5 times -10 is -4. I can see that there's only one variable here, so I definitely have one solution. So I'm going to continue with my inverse operations. And there is my one solution, 3. For question number 13, I have matching variables, so I look at the constants. If the constants are not a match, then there is no solution. I can prove that there's no solution by using inverse operations to eliminate my variable, and notice that the remaining sentence is not true. 5 can never be equal to -2. Alright, last section. Graph the system of equations on the same coordinate graph and find the solution. So I notice here on number 1 that my equation, or number 14, that my equation is written in slope-intercept form. So I start by graphing my y-intercept, which is +5, and then I follow my slope. Now remember, slope needs to be a fraction, so if it's not a fraction, you need to fill in those invisible ones. So my slope is rise of 2, run of 1. Rise of 2, run of 1. So up 2, right 1. I can also reverse that. Down 2, left 1. Down 2, left 1. Down 2, left 1. By reversing it, I allow myself to have some accuracy as I draw my line. Because remember, you're looking for the intersection of these two lines. So the longer the line is, the easier it will be to find the intersection. So my second point has a y-intercept of 4, and the slope is invisible, so that means it's 1 over 1. Up 1, right 1, up 1, right 1, up 1, right 1. Looks like I'm getting further away from my line, so I'm going to reverse that. Down 1, left 1, and there it is. That's the intersection. After you draw your system, you should label at least one line, preferably both. And then it asks me to name that point of intersection, known as the solution. So that point is -1, +3. You put a comma in between. That's an ordered pair. That's a point. Question 15. -2x plus 3. So I'm going to start graphing at 3. And then I'm going to go down to +1. Right? -2, +1. Down and right. I can also reverse it, go up and left. Draw my line, my label, and then move on to sentence 2, which has the same y-intercept. So I found the intersection already, but I have to draw both lines completely, so I follow this slope of rise of 1, run of 2. Rise of 1, run of 2. Draw my line, label it, and name that point of intersection right there. Name that point of intersection, okay? Which happens to be the y-intercept. They both share the point 0, 3. Now the third one here was done for you. It just asks you to name this point of intersection right there. That's known as the solution to the system. And that point is on the x-axis of 5 and on the y-axis of 3. So it's 5, 3. The last section asks you to solve the system algebraically. And when you use the elimination method, you add your two systems together and hopefully one of your letters eliminates. After you solve for that first variable, you have to do the problem again by substituting in this value into any one of these original sentences. I'm going to choose the second sentence because it has all positive values. I'm going to erase and replace my substitute letter, which is x, and the replacement value is 10. So 20 plus y equals 19, minus 20 from both sides, and I get my second answer. That's it. Let's try it again over here on number 18, where the x's eliminate this time. Don't forget, after you find your first answer, you need to erase and replace. So I'm going to use the second sentence again, but this time I'm going to erase the letter y because the value I found was y. I'm going to replace it with the substitute value, which is -1. So 6x minus 4 equals -10, plus 4 to each side. 6x equals -6, and x is equal to -1. All right, give your work a try. Good luck.